Humanity stands on threshold of next great space adventure. We are preparing bold missions beyond Earth's familiar boundaries. Scientists and engineers are reshaping future of interplanetary travel. Moon missions will soon establish permanent human presence. Their Mars exploration programs aim to unlock ancient planetary secrets. Private companies are accelerating development of reusable rocket systems. NASA and international partners collaborate on deep space initiatives. Future astronauts will face extreme environments and unknown challenges. New technologies enable faster and safer journeys across cosmos. Space habitats will support long-term survival beyond Earth. Robotic explorers are already mapping distant lunar terrain regions. Upcoming lunar bases will support scientific research missions directly. Human colonization of Mars remains ambitious but achievable goal. Space agencies invest heavily in next-generation propulsion systems. Interplanetary communication networks will connect Earth and Mars together. Asteroid mining could provide valuable resources for space missions. Space tourism industry is expected to grow rapidly globally. Scientists study radiation effects on human body in space. International Space Station prepares research foundation for future missions. Advanced AI systems will assist astronauts during long voyages. New lunar landers are designed for precision and safety. SpaceX Starship represents major leap in reusable spacecraft technology. Moon resources like water ice may support future colonies. Deep space telescopes continue revealing mysteries of universe itself. Human survival in space depends on advanced life support. International collaborations reduce costs and increase mission success rates. Future Mars rovers will explore regions never seen before. Orbital stations around Moon will serve as staging points. Space medicine research improves astronaut health and performance outcomes. Reusable rockets significantly lower cost of space access dramatically. NASA Artemis program aims to return humans to lunar surface. Private lunar landings mark new era of exploration activity. Solar power systems will sustain long-term space habitats. Cosmic radiation shielding remains critical challenge for astronauts today. Spacecraft navigation improves using advanced autonomous algorithms. Systems. Now interplanetary supply chains will support long-duration missions successfully. Moon bases could become gateways to deeper space travel. Engineers design habitats capable of protecting humans from radiation. Future Mars missions require months of interplanetary travel time. Space exploration inspires next generation of scientists worldwide today. New propulsion methods may reduce travel time dramatically soon. International space law governs activities beyond Earth's atmosphere. Strictly, robotic missions pave way for human exploration expansion globally. Lunar soil analysis reveals clues about solar system history. Space habitats require continuous maintenance and technological upgrades constantly. Astrophysicists predict exciting discoveries in coming decades ahead for humanity. Moon missions will test technologies for Mars. Exploration. Future spacecraft shielding technology continues evolving rapidly with new materials. Innovations. Deep space missions demand unprecedented levels of precision engineering. Future lunar settlements may support permanent human communities there. Space exploration budgets continue increasing across many nations globally. Advanced robotics will perform dangerous tasks in space missions. Orbital debris management becomes a critical issue for satellites. Today, space missions increasingly rely on real-time data analysis. Human Mars settlement planning advances steadily through research efforts. New telescopes uncover distant galaxies and cosmic phenomena. Today, spacecraft docking technology improves mission safety significantly, and reliability. International Mars missions focus on sustainability and survival strategies. Lunar exploration paves way for future human expansion beyond space agencies. Test innovative habitats in extreme environments carefully. Rocket launches become more frequent and efficient worldwide. Today, future astronauts will rely heavily on AI assistance systems. Space exploration fosters global cooperation and scientific progress. Today, Mars rovers continue sending valuable data to Earth constantly. future space stations will orbit both Moon and Mars. Interplanetary travel technologies evolve faster than ever before. Now, space mining operations could revolutionize resource acquisition in future missions. Lunar gateways will enable sustained exploration beyond Earth orbit. Humanity prepares for interstellar future beyond Mars missions. Soon, space exploration represents ultimate frontier of human ambition today. The journey to Mars begins with careful mission planning. Engineers simulate every possible scenario before rocket launches occur. Astronaut training programs now include Mars survival simulations. Extensively lunar missions act as stepping stones toward deeper space. Spacecraft systems must endure extreme temperature fluctuations during travel. Advanced navigation tools ensure precise trajectory corrections in space. Communication delays between Earth and Mars present major challenges. Scientists develop autonomous systems to support distant operations efficiently. Future colonies may rely on in situ resource utilization. Oxygen production from lunar soil is being actively tested. Mars' atmosphere presents both opportunities and serious engineering obstacles. Space agencies prioritize crew safety in all mission designs. Robotics play a crucial role in preparing planetary surfaces beforehand. Human psychology in isolation remains key research area. Today, space habitats must mimic Earth conditions for human survival. Radiation exposure mitigation remains critical focus of ongoing studies. Next-generation rockets aim for higher efficiency and reusability. Interplanetary missions require precise fuel management and optimization strategies. Scientists explore cryogenic fuel storage for deep space travel. Lunar orbit stations will support Mars. Mission logistics operations, international collaboration strengthens knowledge sharing between space agencies worldwide. Artificial intelligence helps monitor spacecraft health during missions continuously. Space medicine studies, bone loss in microgravity environments. Extensively, future astronauts may spend years away from Earth. Mars surface exploration demands highly durable robotic equipment systems. Landing large payloads safely remains a technical challenge for engineers. Space elevators remain theoretical but highly promising transportation concept. Reusable spacecraft reduce cost barriers for frequent exploration missions. Lunar mining could provide essential materials for spacecraft construction. Deep space communication networks rely on satellite constellations globally. Astronauts will cultivate crops in controlled space environments. Soon Mars. Dust storms pose significant risks to solar power. Engineers design backup systems for every critical mission component. Space agencies test landing technologies in simulated Martian environments. Future missions may include hybrid human-robotic exploration teams. Orbital refueling stations could extend spacecraft mission durations significantly. Space exploration drives innovation across multiple scientific disciplines. Worldwide, advanced shielding materials protect against cosmic radiation exposure risks. Crew selection processes emphasize psychological and physical resilience factors. Mars colonization concepts include underground habitat development strategies. Lunar research helps refine technologies for interplanetary survival systems. Spacecraft landing precision improves through advanced sensor integration systems. Private companies invest heavily in Mars. Exploration technologies, development. Space habitats require closed-loop life support systems constantly. Mission control centers operate continuously, monitoring spacecraft status globally. Astronauts undergo extensive isolation training before long-duration missions. Space exploration fuels international competition and collaboration simultaneously. Today, scientific experiments conducted in space benefit life on Earth. Future missions aim to uncover signs of past life. Mars exploration may reveal evidence of ancient water systems. Spacecraft heat shields protect during atmospheric entry phases. Successfully, lunar bases will support astronomical research, and deep space observation engineers develop modular habitats for scalable space settlement expansion. Space exploration missions require precise timing for planetary alignment. Astronauts depend on advanced medical systems for emergency situations. Mars communication satellites ensure constant data transmission back Earth. Space mining technology could transform global economic resource systems. Future rockets may use nuclear propulsion for faster travel. Space agencies conduct regular simulations to improve mission readiness. Lunar surface vehicles are being designed for rugged terrain. Mars mission timelines depend heavily on planetary orbital cycles. Space exploration inspires technological breakthroughs in everyday applications globally. International agreements guide peaceful exploration of outer space environments. Space habitats must protect against micrometeorite impacts continuously. Always, autonomous drones will map Martian terrain before human arrival. Scientists continue studying long-term effects of space travel. Future missions aim to establish sustainable presence beyond Earth. Spacecraft docking systems improve efficiency of orbital operations significantly. Mars missions represent humanity's bold step into cosmic future. Space exploration unites humanity toward Shar. Getting to Mars isn't just about building a rocket. You can only launch when Earth and Mars align, and that window opens once every 26 months. But even with perfect timing, the spacecraft has to survive rocket launch vibrations that would tear most structures apart. So engineers test everything in high-fidelity simulations before anything leaves the ground. Once you're there, autonomous AI has to make real-time decisions because communication delays make remote control impossible. And the habitats themselves need radiation shielding, closed-loop recycling, and the ability to handle temperature swings that would freeze or cook you. Every system has to work perfectly because there's no resupply mission coming to save you. Humanity's next era begins with expansion beyond Earth. Space agencies prepare final phase missions toward Mars. Settlement lunar infrastructure will support continuous human activity operations. Engineers finalize designs for long-duration space habitats. Astronauts prepare mentally for extreme isolation and distance. Mars colonies will require self-sustaining life support systems. Advanced propulsion will unlock faster interplanetary travel possibilities. Space exploration demands unprecedented global cooperation and unity. Robotic missions will precede human arrival on Mars. Lunar bases will act as experimental research platforms. Scientists study soil composition for potential resource extraction. Space habitats integrate renewable energy systems for survival. Communication networks expand to support interplanetary connectivity needs. Future missions focus on long-term sustainability in space. Space agencies test emergency evacuation protocols repeatedly and thoroughly. Mars surface vehicles are engineered for extreme terrain conditions. Astronauts will rely on advanced automation for daily tasks. Space exploration pushes boundaries of modern engineering capabilities. Lunar missions validate critical technologies. For deep space travel, Mars missions require years of continuous planning and execution. Space medicine advances ensure human survival in microgravity environments. Engineers design protective shields against radiation and debris. Autonomous systems manage complex spacecraft operations without delay. Space habitats include advanced filtration and recycling mechanisms. Lunar resources reduce dependency on Earth-supplied materials. Mars exploration aims to uncover potential signs of life. Space agencies collaborate on global interplanetary exploration roadmap. Future astronauts will establish first permanent extraterrestrial settlements. Space mining could transform future global economic structures. Interplanetary travel becomes more efficient through reusable technology. Lunar orbit stations support deep space mission logistics. Mars colonization plans include modular expandable habitat systems. Artificial intelligence supports mission control and decision-making. Space exploration inspires innovation across multiple industries worldwide. Scientists analyze atmospheric data for planetary habitability studies. Future missions include exploration of moons around Mars. spacecraft systems evolve for long-term mission durability. Lunar missions pave paths for sustainable Mars exploration programs. Mars settlements may rely on underground living environments. Space agencies continue developing advanced radiation protection systems. Astronauts undergo rigorous preparation for multi-year missions. Space exploration encourages peaceful cooperation among global nations. Future propulsion systems may enable interstellar travel. Someday, lunar habitats will test closed-loop life support. Mars rovers continue mapping unexplored planetary regions. Thoroughly space communication latency shapes mission design and operations. Engineers build next-generation, reusable spacecraft for exploration. Human presence on Mars represents historic scientific achievement. Space exploration unlocks deeper understanding of universe origins. Lunar missions support development of permanent off-world bases. Mars missions require careful resource management and planning. Advanced robotics assist construction of extraterrestrial habitats. Efficiently, space agencies simulate long-term survival scenarios extensively. Interplanetary navigation improves through AI-driven guidance systems. Future space colonies aim for complete self-sufficiency. Space exploration continues expanding humanity's reach into cosmos. Lunar and Mars missions mark turning point in history. Scientists prepare for discoveries that may reshape knowledge. Space technology advancements benefit life on Earth significantly. Future astronauts will become pioneers of new worlds. Mars exploration symbolizes human curiosity and determination. Combined space habitats ensure protection from harsh extraterrestrial environments. International partnerships strengthen future exploration success probabilities greatly. Space missions will define next chapter of civilization. Lunar infrastructure supports gateway to deeper space exploration. Mars colonization represents humanity's boldest technological endeavor ever. Space exploration transforms imagination into achievable scientific reality. Future generations will inherit interplanetary human presence. Legacy. Humanity steps forward into multi-planetary existence. Future. The universe awaits our exploration beyond known boundaries.